Hello, welcome once again to another session of Calculus 1. In this session, we will be talking about maximum and minimum of functions. Particularly, we're talking about locating these maximums and minimums on a closed interval. We call it locating absolute extrema on a closed interval. Let f be a continuous function over a closed interval, a closed bounded interval. The absolute maximum of f over I and the absolute minimum of f over I must occur at the endpoints or at critical points of f in I. Usually this interval is denoted by two x values, a and b, with brackets around them. So what this is saying is that if we have a closed interval, there will exist an absolute maximum and an absolute minimum. And this absolute maximum and minimum will occur either at the end points of the interval, that is either at a or at x equals b, or it will occur, or they will occur somewhere along the interval. But this somewhere along the interval between the two endpoints must be at a critical point, right? Or maybe one or more critical points within this interval. Remember how we calculated critical points in the previous session? We took the derivative and set that derivative equal to 0 because we are on a differentiable function. Okay, so let us look at the steps. Steps in locating absolute extrema on the closed interval a, b. First of all, evaluate f at the endpoints. Evaluate f at the endpoints, x equals a and x equals b. Then find all the critical points of f over the interval a, b. That is between, not at the endpoints now, but between the two endpoints. That is why you see parentheses here. And evaluate f over those critical points. Then, in part C, we're doing comparisons. Your comparisons of the function values at the endpoints and the function values at the critical points. Now, the maximum or minimum of f will occur at these points. The largest value is the absolute maximum of f, and the smallest value is the absolute minimum of f. So then, first of all, take the function values or find the function values at the endpoints. Then, find the critical points. Then, find the function value at the critical points. The third step, you compare all the function values that you found, the two other endpoints and the function values at the critical points. The largest of all these is our maximum, and the smallest of all these values is our minimum value. So let's look at some examples. Find the absolute maximum and absolute minimum of the following functions in the interval that the values of the functions occurs. F of x is equal to negative x squared plus 3x minus 2 over the interval 1, 3 inclusive. And f of x is equal to negative x squared plus 3x to the 2/3 over the interval 0, 2. Okay, so first of all, we're trying to find the maximum, the absolute maximum and absolute minimum of this function. F of x is equal to negative x squared plus 3x minus 2 on the interval 1, 3. So step 1, we want to find the function values at the endpoints 1 and 3. So then, step 1, we find f of 1, plug in 1 where we see x in our original function, that's negative of 1 squared, plus 3 times 1 minus 2, And you put that in your calculator, you should get 0, or you can just look at it. It's going to be -1 plus 3 minus 2. It's 2 minus 2, that's equal to 0. F of 3 is equal to the negative of 3 squared plus 3 times 3 minus 2. The negative of 3 squared, that's -9, plus 9, that's 0, minus 2, that gives -2. So we have found 2 of our values that we want to compare. This one and this second one. Next, in step 2, we want to find the critical points. To find the critical points, we must find the derivative. Derivative of -x squared plus 3x minus 2 by our power rule will become -2x plus 3. Then we set this derivative equal to 0 to find our critical point. So -2x plus 3 equals 0 means that x will be equal to 3 over 2. Next step, we want to find the f of the critical point. So that's the f of 3 over 2 is going to be -3 over 2 squared plus 3 times 3 over 2 minus 2, and that should give you 1/4. Now, step 3, we want to compare these 3 values that I've circled here in blue. These 3 values are 0, -2, and 1/4. Which of these is the largest? The one that is the largest will be our absolute maximum. Which of these is the smallest? The smallest of these will be our absolute minimum. So we compare the function values of the endpoints and at the critical point. The lowest of these is at f of 3 equals -2. So the absolute minimum is -2, or y equals -2, or we say f of x equals -2 when x equals 3. So we can write it is -2 when x equals 3, or we can say the absolute minimum f of x equals -2 when x equals 3, or you want to say y equals -2 when x equals 3. That's fine. So the absolute minimum value is -2 when x equals 3. What about the absolute maximum? The absolute maximum then is our highest number, which is 1/4. So the absolute maximum, occurs at f of the 3/2, which is 1/4. And so the absolute maximum, you can say that is f of x equals 1/4, or you can just say it's just equal to 1/4 when x equals 3/2. And we're done. Let us look at another problem. F of x is equal to -x squared plus 3x to the 2/3 over the interval 0, 2. First of all, we want to find the function values at the endpoints. The endpoints are 0 and 2. So we find f of 0 and f of 2. F of 0, -0 squared plus 3 times 0, the 2/3, that will be equal to 0. So we found one of them. F of 2 is equal to -2 squared minus 3 times 2 raised to the 2/3, and if you put that in your calculator, that should give you 0.762. So we found the function values at the endpoints. Next, we're going to find the function value within the interval, but not including the x points, at a critical point within the interval. What is the critical point? The critical point is where we find our derivative and set that equal to 0. Finding that x value will give us our critical point. So f prime of x is equal to -2x plus 2 over x to the 1/3. That is our derivative. We can make this one common denominator, and this will become the same as -2x to the 4/3 plus 2 over x to the 1/3. Then you want to set this derivative equal to 0. We set the derivative equal to 0. We have -2x to the 4/3 plus 2 all over x to the 1/3 equals 0. So -2 x to the 4/3 plus 2 equals 0. Continue to solve for x. Negative 2 x to the 4/3 equals negative 2. So x to the 4/3 equals 1. So x will be equal to plus or minus 1. So we have two critical points. X equals plus or minus 1. However, we will only choose x equals 1. Why? Because the x equals 1 lie within our interval. We choose x equals 1 because that is the only x value that lies in our interval. Then we do the f of 1. The f of 1, you plug 1 into our original function. So that's going to be negative 1 squared plus 3 times 1 to the 2/3. 1 squared times 1 squared times 3. Negative 1 squared times 3 times 1 to the 2/3. So that's going to be like negative 1 plus 3. That would be equal to 2. So this is our critical value, or the f of our critical value. So we're comparing 2, we're comparing 0 and 0.762, and to say which of these is the highest. So since we know that 2 is the highest, that means our absolute maximum will be 2, right? Or if you want to write y equals 2 or f of x equals 2, that's fine, okay? But that value is 2, right? When x equals 1, the absolute minimum will be at f of x equals 0, okay? F of x equals 0, or you could just say the absolute value is 0. Absolute value is 0 when x equals 0. The absolute minimum, is 0 when x equals 0. And that wraps it up for our location of our x streamer. Thanks so very much for watching. Please remember to like and subscribe, and we'll see you next lesson.